Hi everyone, in this video we will solve some limits involving trigonometric functions. So this is part A, and you have to find limit tan 2x minus tan 4x divided by x minus pi over 2 when x goes to pi over 2. Pay attention in any limit problem. First you have to use direct substitution and you have to check if it is 0 over 0 or not. For this one it's easy to find that the direct substitution is 0 over 0. Here we have a hint for solving. Let u equals x minus pi over 2. By this hint you can see that x equals u plus pi over 2. And again x goes to pi over 2 in our question. Okay, since you have to write the limit in terms of u, so you have to know u goes to what? U goes to x minus pi over 2, but x equals or goes to pi over 2. So u goes to pi over 2 minus pi over 2, which means that u goes to 0. So we will write the limit again. Our limit is limit tan 2x, but x equals u plus pi over 2 minus tan 4x, which is tan 4 multiplied by u plus pi over 2, all divided by x minus pi over 2, which is u, when u goes to 0. Now we have a new limit with a new variable inside. Now you have to multiply 2 and multiply 4, and you will get limit tan 2u plus pi minus tan 4u plus 2 pi divided by u when u goes to 0. Now one of the most important identities for trigonometric functions, that tan 2u plus pi equals tan u and tan 4u plus 2 pi equals tan 4u. So our limit will be limit of tan 2u, because you can cancel pi, and here you can cancel 2 pi, and we get minus tan 4u divided by u when u goes to 0. Now you have to separate the limit, but pay attention, when you separate two limits you have to check that each limit have a direct substitution 0 over 0. So the limit will be limit tan 2u divided by u when u goes to 0 minus limit tan 4u divided by u when u goes to 0. Now for the first limit, it is 2 over 1, because we have 2 divided by 1, coefficient up divided by coefficient down, and here we have 4 over 1, so we have minus 4 over 1, and 2 minus 4 equals negative 2. In part B you have to find limit cosine squared x minus sine squared x minus square root of cosine 2x divided by x squared when x goes to 0. So firstly you have to rewrite, as you know, cosine squared x equals 1 minus sine squared x, so we can write this cosine squared x as 1 minus sine squared x. Then we have 1 minus sine squared x minus sine squared x, so our limit will be limit 1 minus 2 sine squared x minus square root of cosine 2x divided by x squared when x goes to 0. Now you have to separate the limit, okay? So we can take firstly negative 2 sine squared x, and it will be limit negative 2 sine squared x divided by x squared when x goes to 0. And the second limit, you have to group this one with this one, and you will get limit 1 minus square root of cosine 2x divided by x squared when x goes to 0. Let me say that the first limit is a and the second limit is b. So for the first one, or the first limit, we have limit negative 2 multiplied by sine x over x squared when x goes to 0. And as you know, limit sine mx over nx equals m over 1, m over n. Here we have 1 over 1. So the answer of the first limit is negative 2 multiplied by 1 over 1 squared. And this is equals to negative 2. Now for the second limit, you have to use the conjugate, because we have limit 1 minus square root of cosine 2x divided by x squared. When x goes to 0. So you have to multiply up and down by the conjugate of a numerator. So multiplied by 1 plus square root of cosine 2x divided by 1 plus square root of cosine 2x. Now if you multiply an expression with its conjugate, this is the answer for our step 1 minus square root of cosine 2x times 1 plus square root of cosine 2x equals the first one squared minus the second one squared. The second one is square root, so when you put square you will cancel the radical, and 1 square equals to 1. So we have 1 minus cosine 2x. So this is equals limit 1 minus cosine 2x divided by x squared times 1 plus square root of cosine 2x when x goes to 0. Now again you have to use also the conjugate technique, because up we have 1 minus cosine 2x, so you have to multiply it by 1 plus cosine 2x divided by 1 plus cosine 2x. So we use the conjugate twice in this question. Now 1 minus cosine 2x times 1 plus cosine 2x equals the first one square minus the second one square. So we have 1 minus cosine square 2x. And as a remarkable identity, 1 minus cosine square equals to secant square the same angle 2x. So the limit will be 1 minus cosine squared 2x divided by x squared multiplied by 1 plus square root of cosine 2x multiplied by 1 plus cosine 2x when x goes to 0. And 1 minus cosine squared 2x equals to sine squared 2x. So we can remove this one and put instead sine squared 2x. The next step is to separate the limit. So you have to take these terms from numerator and denominator, and you will get limit sine 2x divided by x all squared when x goes to 0 multiplied by limit of the remaining functions 1 over 1 plus square root of cosine 2x multiplied by 1 plus cosine 2x when x goes to 0. Now for the first limit, the answer is 2 over 1 squared, and for the second limit you have to use the direct substitution. So we have 1 over 1 plus radical cosine 0, which is 1, so we have 1 plus 1, which is 2 for the first bracket, and for the second bracket we have also 1 plus 1, which is 2. So totally we have 4 for the first bracket, and for the second bracket we have 1 over 4, and the answer of the second limit b is 1. So what is the answer of my limit? The answer is, this is our limit, and totally it will be a plus b, and for the limit a the answer is -2 plus 1, which is equals to -1. So this is the final answer of our limit. In part C, you have limit cosine a minus x divided by x minus pi over 2 when x goes to pi over 2 equals to b, and you have to find the values of a and b where a have an interval from 0 to 3 pi over 2. Now, as you know, you have to use first the direct substitution for the limit. So if you substitute pi over 2 in our limit, you will get cosine a minus pi over 2 divided by pi over 2 minus pi over 2, which is equals to cosine a minus pi over 2 divided by 0. Now if the limit something divided by 0 and the limit exists and equal a number, so the numerator must be 0, because we have, or we get an answer for this limit if we have the direct substitution 0 over 0. So by this discussion you will find that cosine a minus pi over 2 equal to 0. Now you have to find the angle. When you substitute inside cosine you will get 0, and as you know that cosine pi over 2 equal to 0, cosine 3 pi over 2 equal to 0, cosine 5 pi over 2 equal to 0, 7 pi over 2 equal to 0, cosine 9 pi over 2 equal etc. Okay, so firstly you have to take the angle as pi over 2. So firstly put the angle inside. A minus pi over 2 equals pi over 2, because the angle pi over 2 make cosine equal to 0. By solving and add pi over 2 to both sides, you will get a equals to pi. Now what about pi? Pi belongs to the interval given in the question from 0 to 3 pi over 2. So the first one, or the first value of a, is a equals to pi. Now you have to take another angle, which is 3 pi over 2, and you have to put the inside angle a minus pi over 2 equals to 3 pi over 2. By add pi over 2 to both sides, you will get a equals 3 pi over 2 plus pi over 2, which is 4 pi over 2, and this gives us 2 pi, and 2 pi does not belong to the interval from 0 to 3 pi over 2. So this is rejected, and all the angles here will be rejected. So we have only a equals to pi, the value of pi and the value of a in our interval from 0 to 3 pi over 2. So this is the value of a. Now you have to find the limit, because we want to find a and b. What about b? B is the limit, or the value of limit. So you have to write the limit again with the value of a inside. So we have limit cosine a, which is pi minus x, divided by x minus pi over 2 when x goes to pi over 2. By direct substitution you will get that this limit 0 over 0, so you have to work. And you know that cosine pi minus x equals negative cosine x. So this is equals to limit negative cosine x divided by x minus pi over 2 when x goes to pi over 2. Now the suitable way to find this limit is to substitute u equals x minus pi over 2 to make the denominator with one variable, with one term expression, and x consequently equal to u plus pi over 2. Now our x goes to pi over 2. Our x goes to pi over 2 and u goes to 0 because pi over 2 minus pi over 2 equal to 0. So you have to write the limit again with u substitution, and you will get limit negative cosine x, negative cosine x, which is u plus pi over 2, divided by x minus pi over 2, which is directly equals to u when u goes to 0. Now, as you know, that cosine A plus B equals cosine A cosine B minus sine A sine B. So this is A and this is B in our equation. So the limit will be limit negative cosine u cosine pi over 2 minus sine u sine pi over 2 divided by u when u goes to 0. Now what about this limit? Now pay attention. Cosine pi over 2 equal to 0, equal to 0, so this term will be 0, and sine pi over 2 equals to 1. So our limit is limit, we have negative sine u, so it will be sine u over u when u goes to 0, and this is equals to 1. So b equals to 1. So the values of a and b are pi and 1. And that's it. Thank you.